The name of the game in manufacturing is good parts out the door. To do that, you have to minimize downtime. To minimize downtime, you need properly trained technical people, technical support people. In the case of our training, we train people to troubleshoot and work with PLCs in automation. Starting with the instructor needs to be someone that has thousands of hours, at least hundreds, on the shop floor doing what he's training the people to do. Secondly, the training material should be developed by someone with the same experience. You cannot troubleshoot a system that you're not intimately familiar with. It'd be like troubleshooting a car that won't start. Did the motor turn over? Do you have ignition? Do you have gas? Now that seems relatively simple, but when it comes to actually repairing those things or determining what the problem is, that needs to be learned from an experienced mechanic. I have thousands of hours on the shop floor doing troubleshooting and thousands of hours developing the materials that I use in my training programs. A key thing to remember about the instructor and the relationship with the learners. If the learner doesn't have a sense that the instructor has time in the trenches doing this kind of work, then their ability to remember what they've been told is weakened, because when the brain processes and develops memories through the hippocampus, there's an emotion that's attached to it. And this kind of an emotion is like a dopamine that strengthens the memory because the learner is listening more intently, intentional listening, because they believe this person knows what they're talking about. That cannot be overemphasized when it comes to having a live instructor in front of your technical support people to train them, who gives them the impression that they know what they're doing. Always keep that in mind. Thank you. When I say thousands of hours, I really mean tens of thousands of hours. Beginning in the Marine Corps, Vietnam, I was a ground pounder, but my secondary MOS was microwave radio technician. So I started out ground pounding and repairing microwave radio equipment in the Marine Corps. I left the Marine Corps and started working, obviously, as an electronics technician. From there, I went to an electronics instructor, and I taught a 2-year program teaching electronics. Everything you can imagine involved with electronics. And from there, I went to a college to teach solar and wind energy and electronics. And from there, I went to Allen Bradley to teach CNC, computerized numerical control. When I left there, I went to working as a controls engineer full-time. And eventually, after a number of years, went to work for one of Allen Bradley Rockwell Automation's best distributors as a course developer and trainer. And I did all the training for PLC, HMI, and NetLinks. When I left there, the next 10 or more years of my career has been as a self-employed controls engineer and trainer. So overall, I have more than 70,000 hours of experience combined in electronics as a technician, a controls engineer, and teaching. So that's pretty much a summary of my resume. And in 3 of those positions, I did course development. I did course development a tiny bit in the Marine Corps. I had a brush with doing M60 machine gun training. That doesn't apply, so let's skip that. But as an electronics instructor, I taught a complete 2-year program, but I did a lot of course development and training aid development during that time. And then as a CNC instructor at Allen Bradley, I developed all my collateral for training. And then as a controls engineer and technical trainer for a distributor, I did all my own course development and training. So all of the materials that I have that I use in my classes, I developed and wrote it. Now I did learn on the backs of other people, so I didn't just dream it all up by myself. But the point is, I authored the material that we use in our classes. Now let's look at the material. Most people involved in education have seen this cone of learning before. And there's probably 100 variations of this cone, but they all show the same categories. So what we're primarily interested in here are your five senses, and of course reading, which is at the top, and the cone is basically saying you remember 10% of what you read, 20% of what we hear, and 30% of what we see. However, this is a little misleading because it's cumulative. So we start with reading, to that we add hearing, and to that we add seeing. Seeing is the most powerful of the sensory perceptions that we have, because the eye is the second most complicated, complex organ in our body, the brain being the most complicated. So the more of these senses or sensory perceptions that you add when you're training, so the more you engage all of the senses, the sensory perception of the students, the stronger are going to be their memories of the information, and the better the recall and retention. So besides seeing, we have interaction. Interaction is more episodic in the sense that the discussions that went on in class between the lab partners and between the lab participants and the instructor or the lab assistant. So we normally set up our classes with 2 people to a station. 1 per station works out for some, but does not work out well for all. 3 is too many. 2 is the perfect number per station, because if one gets stuck, the other one usually has some way to keep it moving. And so there's this interaction between the 2 at the lab station. So although a lot of people say, well, I'd rather work by myself, in reality, it's overall more effective if they work in pairs. Interaction. And then hands-on, of course, that's the big one. So when you look at this pyramid, you look at the percentages, you can't really separate these. So if you start out with reading, hearing, and seeing, it says 50% of what we see and hear. So without any interaction, it's kind of a limit of 50%. If you add interaction, then it jumps to 70%, and then up to 90% or better with actually doing it the hands-on. And this is all about involving different sections of the brain in the learning process. So if you look at this simplified illustration, hearing, vision, taste, touch, and smell. Now, hopefully there's no smell involved in our classes. The touch involves the motor skills paired up with the vision and the hearing and the visualization. So if you look at this, an additional illustration of the brain here, and you look at the sensory cortex, motor cortex, the occipital lobe, which is in the back, that's the visual association and visual cortex. So the cortex, a large part of the brain, is made up of neurons. And your brain, it's estimated, has close to 120 billion neurons. And if you compare that number of neurons and all the interconnections made between them, you actually have a system in complexity that's greater than the known universe. And so when you look at these neurons here and you see all the clutter, all the little branches like going out from them, those are elements of your memory. So when you, right now, you're thinking, and your thought is producing proteins that are forming dendrites. That's the little branch-like things on these neurons. Now, I picked this illustration, even though it's only 3 neurons, and there could be more involved in the memory of the information that you're learning in class. And the occipital lobe, that's sight. The temporal lobe is audible. The discussion's going on. And then, because I only have 3 neurons here, I marked sensory and motor, parietal and frontal lobes, as one group. So in reality, you could have 4 different neurons or groups involved in a memory of one piece of information. And of course, I mentioned in earlier talk that if the student believes the instructor knows what they're talking about, there's a certain emotional aspect that further strengthens the relationship between these individual neurons. So the more neurons you have involved in a piece of information that you're learning that you want to recall out on the shop floor, the better. So functional comprehension and retention, this really says the same thing. They got it in percent, 10, 20, 30, 50, 70, and 80. Now see, they don't say 90. So everybody that creates these graphs has kind of a different number in mind, but you can see that 50% is seen and hearing. If you add collaboration and hands-on, the doing, it makes a huge difference. These are the two manuals that we use for the, we'll call it the RS Logix 500 Micro Starter software. This covers all Slick 500s and all MicroLogics. Step-by-step approach, all the lab projects. You could go on the website and do a what's inside thing to look to see what is in these manuals. These are each, I think, about 250 pages. We don't get through all this material in a 5-day class, but we focus on the fundamentals and basic programming. And what we do is we introduce the learners, the students, into a path of learning, and we include this second volume, Programming in Advanced Subjects. We might even do a project or two out of that manual. But either way, the student leaves with both of these manuals and a complete understanding of how they can move ahead in their education, developing their skill set for this type of technical labor. And we tell them exactly where to get all the information and software, hardware that they need to continue if it's not available at work. This is a typical class setup, and you can see each station has two manuals. Now, we normally do 2 per learning station. This class was set up for 10 people, but only 5 showed up, so I could hardly argue with them. Some of them did actually work together as pairs. Some of them worked by themselves. But this is not typical in that you only see one set of manuals at most workstations. So it is what we sell and deliver is 2 people per workstation. This, and we have a couple people missing out of this picture. I just happen to have this photo. This was the class I did for some engineers in the Navy in Chesapeake, Virginia. Okay, now I talked about neurons. I'm showing you this picture here to show you an actual technical picture of a neuron, and it's got the dendrites. Those are the individual elements of the memory, and then going through the axon, through that myelin sheath to the outputs. So those synapses out there, they connect to other neurons, and that's what connect all these neurons together to give you a reinforced memory. So I just wanted to point out that I wasn't just throwing some weird information at you. I'm actually researching the brain right now to further understand not how to teach better, but why the methods that I'm using seem to work so well. And it's given me some things to think about to improve them even more effective than they are now. So you see these 2 manuals. This is for 500, I call it. Slick 500 MicroLogics. These are the 2 manuals for RS Logix Studio 5000. What is nice, if the student gets a chance to take both of these classes, because in this class, they learn ladder logic and basic PLC stuff, I/O, scans, and everything. In this one, if they've already had the primer, they've already learned ladder logic. 5000, RS Logix Studio 5000 is much more complex than RS Logix 500 or MicroStarter because of the tag structures. So the tag structures, in other words, labeling of memory locations, pointers, registers, it's much more complex and more involved. So if they've already learned ladder logic in the 500, when they take this class, they're looking at the exact same basic landscape, but they're in a different vehicle and they've got the experience of having been there before. So we always recommend that you do the 500 first, then the 5000. I've actually done them in consecutive weeks. Had the students for 2 weeks in a row. This is the trainer for the 500, and you notice that, and also for the 5000. Now the 5000, that shows a Compact Logix L32E, but we also have some newer processors. Nonetheless, both of these learning stations allow the learners to do lab projects that 100% are portable to any version of RS Logic Studio 5000. In addition to 500 and 5000, we also have Connected Components Workbench with the Micro 800. These are the two manuals, hands-on lab project manuals, that we use for our Micro 800 training with Connected Components Workbench. And actually, these two manuals combined have more lab projects than the other two. And this is the hardware trainer, one of the hardware trainers that we use. One thing I did fail to mention was that I actually did course development and training twice for Rockwell Automation. The first time it was actually Allen Bradley before they were purchased by Rockwell. That was the CNC. And then later on for Rockwell Automation in Mayfield Heights, I did course development and training for the hands-on technical training group. It was PLCs, HMIs, and netlinks. So twice I did course development and training for Allen Bradley Rockwell Automation. So that wraps up my qualifications as a teacher, the qualifications of the learning materials, and the lab hardware. I believe I have, if not the best, some of the best training, hands-on, FaceTime instruction in the world for an English speaker. Thank you.